Okay, hi everyone. I hope this video finds you well. So today we are going to talk about lecture 3, and in lecture 3 we are talking about Boolean operators. We are talking about the basics of the if statements, the basics of the while loops, and we are going to practice using if and while loops in if statements and while loops in programs. Introduction to the random numbers. So you can find this lecture in modules in Canvas, and I already started Sandbox 3 project. Here it is. I already started that and prepared it with using namespace std, and it's ready now for me to practice what we have in lecture 3. So, if you are going to ask yourself a question, how does the program make decisions? So, the program is making decisions based on the Boolean operators or Boolean expressions. So, we do this through a true or false decisions. It's like when I ask you, is the number of my students in my 2 sessions of CS 131 less than 200? Now, the answer to that is either yes, which is represented by true, or no, which is represented by false. Now, there is no maybe. There is no way, there's no way that you can say, oh, maybe. No, you have statistics. Now, either this is less than 200 or not. Now, if you're checking equality of a string, now, if this variable is of type string, I can check, is this name equal to Frank? It's like when you're asking, is your name Frank? And the answer is either yes or no. Is temperature greater than or equal 30? So all three of those, we are saying about those that using those Boolean expressions, you can give either true or false answer to make a decision in a program. So saying that again, a Boolean expression is an operation that gives a true or false answer. And the Boolean expression, this, helps you in making decisions. And this is what we are aiming for today. So most Boolean operators checks the relationship between two things. Equals, checking the equality between two entities. Now, one entity could be int and the other is int. One int and the other is character, because we know that we have a strong relationship between the characters and the integers. But it doesn't make sense to say x of type int and this y is of type string. Doesn't make sense. So you check the equality or not equality, or less than or equal, greater than or equal on similar things. Now, something that I have to mention, so less than or equal in math is this. Now, this is in math. Since we don't have characters like this on our keyboard, so we need to check the less than or equal. So this is how we do it. Angle bracket, then followed by equal. If you're looking for greater than or equal, you write it the way you say it. You say greater than first, then equal, right? So you do it this way. So this is the angle bracket that you can find next to the letter M on the keyboard. So the operators and their precedence in the precedence table, those operators, less than or equal, greater than or equal, they come after the insertion and extraction operators in the precedence table. And the equal and not equal, they come after the less than or equal, greater than or equal. And those all come before the assignment operator. This is not checking the equality, remember? This is assignment. Okay, so let's give this a try. I'm going to try things and show you the effect of those and what is the outcome of each of those. So let me just go and copy this code. Here is the code. Now, if you tried this code, let me just put this code in the IDE. So if you do that, then we are just going to enter this. So enter two numbers. When you enter two numbers now, we are going to check the equality of those two numbers and those of type integer. So let me enter two numbers, 1 and 3. Now, as you can see, those are not equal. So the answer to those is false, right? So what I've gotten in here is 0, not false. Let me check the equality for you. When you check the equality, you're going to have 1, which representing the true. But this is not what we want. We want to see the word false, the word true. Now, the way you do it is to force the cout, whenever the cout gets a Boolean result, a Boolean expression result, true or false, to write it as it is, false or true. The way we do it is to use IOStream formatter. The formatter we are going to use, or we can call it stream manipulator. So the format we are going to use is to say cout. Whenever you get a Boolean, show it as alpha. Show it as alpha. Now, if you try this, now I can check the equality and say, okay, 2 and 3, now we see false. If you do 1 and 1 or 2 and 2, 1 and 1, you can see true. Now, what if I don't want to see the false or true, but I want to see the 0 and 1? Then you do no alpha. Just no Boolean alpha. No Boolean alpha. So now if I check 1 and 2, I should get 0 back. See? I got 0, not false. Okay. So, but we actually prefer always to get the Boolean as written in alphabets. Okay. So that showed you 0, non-zero. We used cout alpha. Now, if you want your all your expressions to be 0 alpha, what I suggest always is to put it where we put it in here, at the top of the main, right? Then everything else is going to be in alpha. It's not just for the next thing. No, it's for any other input, any other equality, or any other Boolean expression result after the statement, after this statement. Anything after that is going to be alpha. If you wanted to set it back to 0 and 1 somewhere after that, you can put it in here, and then after this line, you're going to start seeing Boolean alpha. So if I do this, here it is, and I would say, okay, I would do no alpha, and I would check the less than or equal, right? I would check less than or equal. Here's less than or equal. So let me try this. So what I should see is for the equality that says false or true, And for the non-equality, because it comes after this one, I should see 0 and 1. So 2 and 3, this shows false, and then 1 because 2 is less than 3. See that? This is coming because of this one, and any other thing after that. And since we said, okay, we put it back to the initial status, that shows as 1 and 0. Okay, so making decision usually using the if statement, or using the Boolean decision, using the Boolean expression in a loop. Let's start with the if statement. The if statement is if you'd say, if something came true, if something evaluates to true, then do something. So in this case, if num1 equals num2, print this. Otherwise, do not print that. Now, I want you to always memorize the flow charts and understand them. Always memorize them and understand them, because they are critical to your understanding, and they stick in your mind. So this is happening as if, here is the if, Boolean expression, here's the Boolean expression. If this Boolean expression evaluates to true, then do this block. Here is the block, right? This is the block. Otherwise, go out. Skip this block. This is only if. Now, this is the Boolean expression statement. If that became or evaluates to true, then do this block. Now, this is one statement. If it's only one statement, not one line, one statement. A statement ends with a semicolon, remember? So if it's only one statement, you don't have to surround it with curly braces. You don't have to. But if it's more than one statement, then you have to have those. Otherwise, it's going to take only the first line as the true block. And we are going to see that in the next examples. So, if we have multiple lines, always you have to have those. This is what's in here. If you have more than one line, and to be more accurate, if you have more than one statement. Because this word line is misleading a little bit. So greater than one statement, then use curly braces. Otherwise, it's just going to take this one as the true block. And those are going to be evaluated or executed anyway, regardless of this decision. Regardless of the evaluation of this Boolean expression. Now, here is the if this evaluates to false, then this is being skipped. This is this, right? So we skip this line and execute whatever follows that line. Okay, we have another version. The other version is called the if-else. The if-else. If this Boolean expression evaluates to true, do this block. And this block could be one line or multiple lines. Or one statement, multiple statements. One statement, you don't need the curly braces, even though, usually in my coding, I follow a standard that says, whenever you have a statement or else statement, always include those. Whether you have one statement or multiple statements. Because this way I make sure that everything in this, whether it's one line or multiple line, I treat it as a block. This is why I write block in here. So if this Boolean expression evaluates to true, then do this true block. If evaluates to false, then do another block, not just skipping this one, but skip this one and do this one. Let me show you how this is being done. So here it is. I have only one statement and one statement in here, right? So if I have only one statement, I don't need those. I can get rid of those, right? Because I have only one statement in each block. So if num1 equals num2, then I'm doing this one. If this is true. And if I'm going to change this one to this, if this is false, then do this one. True, do this one. False, do this one. Now, let me show you that in animation. So if this evaluates to true, do this one. Else means like in plain English, it's like otherwise. Otherwise, do something else. This is our otherwise, the else. This is our otherwise, the else. So else, do this. Here it is. Else, do this, because the Boolean expression evaluated to false. So if you have more than one line in a block, you would need the curly braces. You would need the curly braces. Now, this way, having the curly braces makes sure that all three statements belong to the same block. So if that evaluates to false, then the whole block, the three statements, are going to be executed. So good practice is always adding the curly braces to your blocks. Now, why did I say always add those? Because let's see it this way. If this evaluates to true, then you have compilation error. Now, if this evaluates to true, then what you say is execute this line. Only this line, remember? Only this line. Why only this line? Because this is the one follows the true. This is a true block. But this line is hanging there, dangling, without even consideration to whether it's part of the block or not. So it's not to the block. And the compilation error happens because that would say, oh, I have else that does not belong to an if. But you would argue that, okay, here's an else and here's the if. So this else follows this if, or connected to this if, right? No, you're wrong, because you separated them with this line. This statement separated the if from the else. So, this is the if statement. This is going to be executed anyway, and the compilation error says that this else is dangling there without any if. It's not. So if you're going to have else, you must have if, because the else is dependent on the Boolean expression of the if. If you don't have if, or if it's separated, like in here, this line is separating the else from if, right? If it's separated, then compilation error. Okay, so if you have this num1 and num2, let's pretend or assume that num1 and num2, those are defined, and the user enters in the cin, because you're asking the user to enter num1 and num2. Let's pretend or assume that the user types 2 and 3. What is the output? What do you think? Now, if you understand what I've said in the previous slides, then you would guess the correct answer is both statements. Both statements. Now, if this evaluates to true, but 2 and 3 makes this false, right? False. But wait a second, is this a block? No, it's not a block. This is only the true block, right? This is true block. So if this is the true block, that makes this the dangling statement, a statement that does not depend on any Boolean expression. So it's going to be executed anyway, whether this is true or false. So if this is going to be evaluated to false because of this, then this is the output. If those are 3 and 3, then both are going to be evaluated, because this again is going to be evaluated anyway. So good practice is always to include the curly braces as part of your if statements or loops, because this defines the block, and you make sure that, okay, this is the block, I don't have dangling statements, I don't have else, without, if, and all these things. Okay, so let's take this one. Please enter a number, then the user enters a number. Now you would say if num equals 5. If num equals 5. Now, what you see in here is that you don't actually check the equality, right? What you say, assign 5 to num. Regardless of what the user entered, you're assigning 5 to num. And the result of the if statement is dependent on what you're assigning. So if you're doing num equal 5, then this is always going to be true, because 5 is a number that is non-zero, because you know that true equal to or equivalent to any non-zero integer. False is equivalent to 0. Now, this is true in C++. In C++, you don't have always to have Boolean expressions in here. You can have numbers. 0 means false. Non-zero, whether it's negative or positive, means true. So this would give you always true. Right? So you'd say your number is equal to 5. Now, always, regardless of this input, this is going to not be executed unless you change this 5 with a 0. So if num equals 0, then this is going to be always executed. So instead of doing num equal 5, because if you dropped 1 equal, then the compiler is going to assume that you're assigning. The way you do it is always having your value that you're checking the number to, the number equality to, or less than, or greater than, or any of these Boolean operators to, have it on the left. Let me just try this with you. Where it is? Here it is. So let me just go there and do this exercise. Let me just copy this. I'm going to prove it to you, play with it so you understand what we have said. Okay, and we need num, right? And num is going to receive, as you can see, I didn't give it any value, so it's going to receive the value from the user. Now let's check if I do this. If I run it and I do this. So enter a number, I would say the number is 17. Now this says your number is equal to 5. But wait a second, I'm checking to 5. No, you are not checking. You're assigning 5 to it. Let's say 0. Now this should always take me to the false statement, right? Because num equals 0. You remember this is dependent on the value we are assigning. So this should say your number is not equal to 5 in any case. So 12 not equal to 5. So basically you're taking a number in here from the user. Yes, you're taking a number from the user and you're assigning this to num. But then you overriding this, right? You're overriding num with the 0. So if I would do this, let me just change this to the actual way. Equal 0 equal num. Now, as you can see, the compiler is not even going to accept it without even me trying. See? That gives you something that says expression must be modifiable value. The left value. This value must be modifiable. Means it must be a variable because it's an assignment. But if I do this, now the compiler is satisfied, right? Now the compiler is satisfied. Okay, so let's go there. We proved this, and this is good. Okay, so a class exercise is you writing the code that does the following. Ask the user for a number. Check to see if the number is even. Even means it's divisible by 2 and the remainder is 0. Give the user a message about their number. Tell them if it's even or odd. Now, pause the video and start working on this number. When you play the video back, I'm going to be solving that for you. Okay, you pause the video now. Okay, assuming you paused the video, you worked on it, and now I'm going to be working on it to see, to show you how it's actually being done. So let me go here, and we said here, and please enter a number. Okay, pretty much everything is ready for me. Now, what I'm going to do is 0 equal to num mod 2? Because num mod 2 is going to check whether the number is basically that gives you the remainder of num divisible by divided by 2. Now if num divided by 2 and the result the remainder is 0, then this is even. So what I would say is, what is the format in here? 35 is an odd number. Okay, I would say your number num and is an, let me just do this, odd this if the result of the this operation the remainder is 0, that means it's even, right? It's even. If you divided something by 2 and the remainder is 0, then it's even. Otherwise, I'm going to take this and replace this with it. So that is odd. So let's try it. Let's try this. So enter number 12. 12 is even. Okay, let's try it again. 11. 11 is odd. Okay, let me just add even number, odd number. That's nicer. When you print right now, it's just going to print an even number or an odd number, not just an even or an odd. So 13 is an odd number. Okay, that's good. Now we have done this. That was easy. Now here is the result. Now what you see in here what you see in here is me doing num mod 2 equal 0. Now you can do that, but remember that we said the safest way is always to have the value to the left, even though it doesn't matter that much, because this is not going to be an assignment, because you have operation here, full operation. If it's just num equal 0, that would matter. But this is full operation, so it doesn't matter that much whether you have the 0 to on the right or the left. But usually we prefer it to be on the left, so you get used to the idea of it. So reviews of the if statement. So you have either the basic if, that is if without else, and never have a semicolon after the condition, because this is going, there is something that you should know. If you have a semicolon in here, this is considered a legitimate statement in C++. Legitimate statement in C++. Why? Because it's called the empty statement. The empty statement. And this, whether this is false or true, the empty statement is going to be executed, which means that the compiler is not doing anything. And this is going to be executed anyway, because one slip of a finger, right, on your keyboard, and you added a semicolon. And remember that always enclose your blocks with the curly braces. Now the if-else statement is if followed by the else. This is going to be executed if it's if the Boolean expression evaluates to true. This is evaluated if the Boolean expression evaluates to false. So one of the bad styles is to have everything in one line, whether it's basic if statement or if-else statements like this. And you would have if Boolean expression in the same line to have the true block, or if Boolean expression, the same line to have true block, else in the same line to have the false block. This is not a good way of writing your code. This is not a good style. This is bad style. It's better always, it's better to have them separated in multiple lines. Have this line come in here, and it's always better also to have this enclosed by the curly braces. Same thing in here. Have them separated, and every block is enclosed with the curly brackets. Like this. This is a good style. Okay. So, now, depending on your preferences, whether to have the curly brace in here, one line after the if and the Boolean expression, or to have it like this, following the Boolean expression in the same line. Those are two good styles. You can use any of them. And this is also a good style for the if-else statement. You can have it like this, or you can have it in here. You can have it like this, or have it in here. Doesn't matter that much, as long as you follow the idea of, or the style of having curly braces always, and separating the if and the condition from the lines, separating them in multiple lines. Okay, also the compiler does not need spaces. This is another, since we are talking about styles, it's always good to mention that for us readers of your code, it's better always to separate the words from the operators with the spaces. So result, a space, equal space. Now this is actually, to me, at least to me, I can see it this way, it's more readable than this one, having everything next to each other. And especially if you have things with underscore. Let me just show you this. I'm going to print this, even though it's not going to be recognized that much. But where is it? It's in here. So I'm going to have this in here, put it in the IDE, and show you something. So let's assume that this is separated by underscore. Let me just do this int, and in here I would do int and all these just to show you how is the final result going to look like, because you won't actually like it. Because now, if I put this way, I know that this is one word, and pretty much everything is recognizable. Even though I would not prefer to have, if you're using something like this, a variable of 2 words in an equation where operators are involved, do not use variables with underscores, because that would mislead some people if they would consider this or think of this as minus, the operator minus, the subtraction operator, not the underscore. Better idea is to have it one word like this, like 2 words as if it's one word. But let me just show you this, how this is so confusing. I will get rid of every space in here. Now, pretty much this is hard for me to read, what separates them, and especially with this, you wouldn't know which one is one word or different words. Having spaces is going to be making your code more readable. Okay, so the dangling else. Let me give you another example of dangling else. And this is always critical because you don't want to confuse your compiler. If you're not using brackets, then you're going to confuse your compiler sometimes, and sometimes you yourself are going to be confused with your own code. Let me show you something. Here is int life equal 100, energy from food equal 100. So, looking at this code, I see that if life is greater than 0, do this, and now, wait a second. We said that if you don't have brackets, then the next line, or to be more accurate, the next statement that follows the if statement is going to be the true block, right? So, do I mean that this is the true block? Yes. And remember that always the line, the statement, the regular statement that is not if, not while, following the if statement is going to be the true block of the closest statement. So this is so confusing to some people, especially people who are not practicing coding very often. So, looking at this code, if life greater than 0, then I would do this, and this is attached to this one, so I would do this if this is true, right? Else, do this. This is so confusing. So, now, you won't know if this else is actually attached or dependent on this if or this if. Can you answer that? No, this is so confusing. But for people with experience, they won't be confused unless they were kind of looking fast at their this code and thinking, okay, maybe if I see those are with the same color, like red and red, then I would know that this is following this one. But actually, this is wrong. This is wrong. Because the rule says else is dependent on the closest if. Now, the closest if is this one, right? So this else is following this if, not this. So you misled yourself because of sometimes the indentation. So let me just take this code. Here it is. I'm taking this code and put that into the IDE. remove these things because I won't need them. Now, let me just do this and do this, because in my intention was having this else depending on this if. So I indented those two, the same number of spaces. I indented those two with the same number of spaces, and thought that this else depending on this, but actually this else, even if it's indented the same way as the if, which would mislead you that this if is depending on this one. No, it's actually depending on this one. So if I would do Control A, and I would go Edit, Advanced, and I would format the code. See? Formatting the code, that means the compiler or the IDE is attaching things to what they're supposed to follow. So the compiler right now says, okay, here is the if, and the whole thing is considered the true block of the if statement. But is this if having any else? The answer is definitely no. This else is depending on this one. This else is depending on this one, or attached to this one. Okay, that said, this is also a little bit confusing, because what you understand is that if I have multiple lines, I would have them surrounded by curly braces. Yes, having this makes sure that, okay, see that where that comes? That makes sure that everything in here is following or in the same block. Everything in here. But this way, you have to understand or have better understanding of what the regular statement means and the Boolean expression dependent statement means. So when we say the first line, we meant the first line of a regular statement. So that is valid. That is valid true block, even though it's not surrounded with curly braces. But this is confusing, right? So it's better always to surround your blocks with the curly braces. That makes me sure that this is the true block. This is the true block. Okay. So here's the explanation that the compiler will connect the else to the nearest if, the closest if available, that does not have the else statement. So when you say this is true. If you said this is also going to compile, but the understanding of it that this if is connected to this else is not true. Okay, so as I said, it's always better to, if you want to connect this if to this else to this if, have curly braces in here, right? Then this makes this if without else basic if, and this if is if with else depending on it. With else depending on it. So it's always better that since you were smart and added this to say, okay, this is my true block, right? And you force the compiler to take this else. Now, when you add curly braces, you're forcing the compiler to attach this else to this if, because it's the closest. But you would say, okay, but wait a second, this is the closest, right? No, it's not the closest, because now this else cannot even see this if, because it's in a block and it's not within its scope, something we call scope. A scope, if you're outside a block, you cannot see what's inside that block. If you're outside a block, like this else, you cannot see what's inside. So you actually don't see the if. The insider if. Okay. we have else if chain, right? We said if else chain. So, in the ancient times, they were doing the if else chain like this. If I would have if, depending on the condition of the previous if, I would have it in else, and I would have it as the block of this if. Now, if this is false, this block is going to be enforced to be executed. If this is false, then this is the false block. If this is false, this is going to be the false block. If this is false, this is false block. But as you can see, this is a little bit confusing and it's not preferred. Let's put it this way. It's not preferred to have it this way. Even though it's going to be working, but we don't prefer it. So what we need is something a little bit elegant, right? More elegant. So having this way, attaching else to the if in one line, this is exactly similar to this. But this will take more cycles from CPU. More cycles from the CPU, which what we call CPU overhead. So, elegantly put, this way is better than the other way. So if this grade is greater than 90, then the grade is A, else if, and you cannot say else until you reach the end. So the else is going to be always at the very end. This is the else. Always at the very end. So the purpose of the else if chain is to find the one right answer. So you cannot say this is true and this is also going to be true. So this is executed and this one. So if that is true, then I'm going to do this one. And I skip everything else. Even though, if the grade is 95, then it's going to be making this true. But it's going to be executing the block of the first true Boolean expression. So it's going to be executing this one, right? And skipping this one. If you have a true, then you do the true block and skip any other false block. Okay, so the alternative for the simple if statement, when I say simple if else statement, then I mean only if and else. Only one if and one else, not the else if chain. The alternative to that is something we call the conditional operator. The conditional operator is question mark followed by the colon. Now, what do you have in here? What you have in here is what we are going to figure that out in the next slide. So here is something we used to see. If Boolean expression do something, else the Boolean expression is false, right? Do another thing. So that could be written as max, because as you can see in both statements in here, we are trying to assign something to max. Right? So max equal Boolean expression. This is where the question mark comes in. You ask yourself a question. Is number 1 greater than number 2? Here is the question point, right? If that is true, assign num to max. Otherwise, else, assign num2 to max. So putting this way, Boolean expression, question mark, true. If this is true, the true block. What do you do if this is true? Assign this to max. What do you do if this is false? Assign this. So now the question is, do we actually need the parentheses? Whenever you see parentheses in programming, always go back to the precedence table. Right? Always go back to the precedence table. Which one comes first? If we have, for example, cout, num1 greater than num2, question mark, num1, then, or num2. So if this is true, print num1. If this is false, print num2. Now, to see that these operators, or those are 1 actually, so the 1 operator, the conditional operator, comes after the insertion and extraction. So let's go back a little bit. So if this is coming after the insertion operator, then we need something to force it to be executed first. What do we force the compiler to do first? What's inside the parentheses? So do this first, then do the insertion operator. Otherwise, this is going to print num and give you a compilation error because it does not recognize this one, right? So you're trying, then this is going to say, okay, you're trying to do greater than. Greater than what? So what greater than num2? Right? It's going to be confusing to the compiler. So the compiler will throw you an error. Okay, so class exercise. On your machine, write the code that does the following. Asking the user for a number, checking if it's even or odd, and show the result. Exactly what we have done before, but right now you're going to do that with the conditional operator. You're going to do that with the conditional operator. Now pause the video, do it, and come back. Okay. Assuming you paused the video, came back to see the answer, here is the answer. You're asking the user for a number, right? Please enter the number, and here is num. Then you say num is an. Now you do either even or odd number. Now you can have even number in here, odd number in here, doesn't matter that much, or you can have just even and odd and the number following that, because this is the most important part we are interested in. It's going to print number anyway. It's going to print is an anyway. And now, depending on your Boolean expression, it's going to print either even or odd. Now, is your number divisible by 2 and the remainder is 0? If yes, then it's even. Print even. Otherwise, print odd. Then number is going to be printed anyway. This is the solution. Now, what does this code do? Now, this code, pretty much you have seen that before in the previous slides, but that wasn't a character. That was a number, and we tried 95, right? So now this is going to check the characters. Whether your character is A, you're going to print this. If its character is B, you're going to print this. If your character grade is C, you're going to print this. If you don't have one of these grades, then you're going to say your grade has a problem. Because what we have in AVCC is A, B, C, D, or F. Now, without the plus and the minus, I mean. But if you say your grade is Q, basically you won't find this grade Q in any grading system in the whole world. So yes, it does have a problem. So what does this code do is basically trying to find the one Boolean expression that evaluates to true. If none of them evaluated to true, none of them. So if that is false, then you're moving to the next one. That is false, you're moving to the next one. And so on until none of them evaluates to true, then this is going to be executed because this is the last false block. Okay, so now let me introduce you to the while loops. So what does the while loop do? If you want to understand what does the while loop does, so what does the while loop do? Then you have to ask yourself a question. What are the advantages of computers that I can use and making the computer doing a job many times without even being tired? So, putting that in another context, the computer is quick, right? It's really quick, and it doesn't get bored. The computer does not get bored. So, the computer can do this many times, anything you want, printing happy, million times without even complaining. And does that in seconds or in milliseconds. So, we want something in programming that would tell the computer do something many times. What is that? You guessed it right. A loop. One of the loops is the while loop. Now the loop is instead of doing this, like printing the code and copying, pasting, instead of doing that, you can print that once without copying and pasting, and stop when a condition becomes false. So the way I'm going to do it right now, or the way I'm going to say it, is critical to you. So what I'm going to say is, as long as a condition evaluates to true, keep doing a block of code. Once this Boolean expression, this one, evaluates to false, stop and skip that code. So let's take a look at how that going to be executed. So we have int num equals 0 in here. Then we say while. Now, while is how you tell the compiler to do things many times. Now in English, I'm going to translate the while, the code while, to English, plain English. As long as num is less than 10, do this block of code. Now remember, this is a block of code, not just the one statement. A block of code, full block of code. We have curly braces, right? If we don't have curly braces, then only this is going to be indent to the while loop, right? Okay, so we have a block of code. If that evaluates true, do this code. What does this code do? This block, printing num equal num, and incrementing num. So num for the first time is going to be 0, while 0 less than 3. Is 0 less than 10? Yes. Then do this code, print num equals 0. Then increment num. Now you can do this as num plus equal 1, right? Or you can even shorten that to num plus. Remember that from lecture 2? So you can do those two actually. So num printing num num equals 0. This printing num equal 1 because that was incremented and checked again. So whenever you finish doing the code block, let me just get rid of all these so this is visible to you. So whenever you finish doing this, you go back to check the condition. If the condition evaluates true, do this again. Then go back to check the condition. Now, how the condition is being changed because of this line, right? This line is changing the condition. What we call the update line. This is the update line. The update statement. This updates num. And remember that the Boolean expression is dependent on the value of num, this value. So if num less than 10, keep doing the code. So the way it's going to be done is if this is true, do the true block. If it's false, do the false block. Okay, in this example, and this is for the previous example. For the previous example, can you guess what num, the last statement to be printed, the last num? Can you guess it? You guess that. If you don't know what is the last num, take this code to the compiler. Take this code to the compiler. Okay. So, going back to this slide. So, assuming num is 5, what is the output of this code? Now, why did I ask you to guess this one? Because I want you to understand what's going on before you move on to this slide. Because this slide is a little bit tricky. So, Boolean expression, if that Boolean expression, we evaluate this true block. If it's false, then we skip this. We skip this true block from here to here, right? We don't evaluate this or we don't execute this true block. What is the output? Now, some of you would say, okay, hello world printed 5 times. Because it's 5 less than 10, yes, true. Print the first hello word. Then, num plus 1, num is 6, and 6 less than 10, yes, print hello word. 7, print hello word. 8, print hello word. 9, print hello world. 10 less than 10, no, so don't print hello world. So you would say you printed hello world 5 times? You said that, right? No, you're mistaken. Because this is not the true block. I misled you. Remember that we don't have curly braces? If we don't have curly braces, then only the first line is going to be the true block. And this line is not dependent on any condition. And it's never going to be executed, to be honest. Why? Because you're saying, is num less than 10? Yes. Print this one. Then go back to check the condition. But you haven't updated the condition. So, is num less than 10? Yes, because it's 5. 5 less than 10. 5 less than 10. 5 less than 10. Keep printing hello there. So this is called infinite loop. Infinite loop is going to be the loop that does not end. So what you need to shut down your program because you cannot ending that in any other way. Okay, so if you have this code, what is going to be executed? What is going to be executed? How many times this is going to be executed? This code block is going to be executed none. 0 number of times. Why? Because of this. Remember, this is empty statement. This empty statement means that while this code, this Boolean expression is true, execute this. Go back to check. Execute this. Because remember, this is a legitimate statement. It's called the empty statement. You have empty statement. You're executing an empty statement. So you're going to have just the cursor blinking. The cursor blinking on your output screen. Okay, so this is the main difference between the if and the while. The if is just going to check whether this is going to be true. This is going to be true. If it's true, doing this and skip, like continue your code. If this is false, skip this code and continue doing your code. But this one, the while, is going to do this one first. Checking the Boolean expression. Is it true? Is it actually true? Yes. Do that. Do not continue your code. Go back to check the Boolean expression again. If it's false, skip this code and continue doing your code. See that? This is why we call it a loop, because it's stuck in here until this one becomes false. So this is the while and this is the if. So, a class exercise. So, ask the user for 10 integers. Return to the user the total of the 10 integers and their average. And the average is going to be in floating point format. So I should see the floating point format if it has a fraction. If it has a fraction. So always think of these questions. What part needs to be repeated? This is going to be your code block or part of your code block. How do I update my condition? How many variables needed? Right? Okay. So pause the video, think about this exercise, do it, and when you do it, you comment the previous code, always comment the previous code, select the whole code, comment that, and continue working on your code in here. Once you're done with this code, let's say that you have another code, comment this one and do that again, because what you're going to do is when you're done, you're going to right click on this one, right click on the tab, and open containing folder, and upload this file in the correspondent daily activity. So you open this one and you submit your code. Now let me just show you how you're going to do it. I'm going to pretend that I'm student, and I'm going to act like I'm a student. So I would go to modules. Oh, I haven't published that. So let me just go back and publish it before I do that. And I publish it as instructor, as your teacher, so you won't have these things. So publishing that means now I can go pretend that I'm student, and I can show you how to upload that. So I would see what you see, and in the modules right now I can see this module 3. I would go to module 3. what you would have is, once you're done, you would have this submit assignment. Submit assignment, you can choose a file, and I'm going, see, this is my sandbox. I'm going to take this, copy that, going back to my browser here, and paste it and open. Now you can see this is my .cpp, right? This is going to have everything I have in there, and you do open. Now it's chosen, and you submit the assignment. Submit the assignment. Now you can do that once you're done. Yes, I would leave the student view and go back to my slides. Okay, now you paused the video, you worked on this one, and you don't submit your file, the one I just showed you how to submit, unless you're done with all the exercises of this lecture. So this is the solution. I'm going to pretend that I have done this solution just now and copy that solution because I want to show you how to here's the solution, right? Now this is the next one. This is the solution I need. So I'm going to copy this and paste it in my, let me just remove this. I pasted in here, so I tried this code. Here it is. Now I'm going to explain to you how this solution works. So enter number 1. So as you can see, what we are asked to do is we enter 10 numbers, right? So what we are going to do is we enter 10 integers. We sum all the integers I entered, and you give me the final results, the total and the average. So going back to our console, 12, 14, 2, 56, 13, negative 5, 34, negative 50, 34 again, and 23. Now we are done with the 10 integers. This is going to say then the total is 133 and the average is 13.3. Let's see how this how I programmed this code. How I programmed this code is I have int, I initialize it to count, I initialize it to 1, total initialized to 0, user input, and I haven't initialized this one because this is going to be taken from the user, right? The values to this one, and this is going to be changing, taken from the user. And I say count less than or equal 10, and don't forget that I have to update this count. Now I ask the user num count, which is going to show you the num1, num2, num3, and so on. Then I ask the user for the input. The user inputs that in here. And then I add this to the total. Now I can do this like this, total equal total plus user input, or just do plus equal, right? Plus equal. This is going to add the user input to the total. And it doesn't matter you do plus plus count, or count plus plus, or count plus equal 1, or count equal count plus 1. All are the same. So it doesn't matter what you do in here, right? So when we do count plus plus, this is going to matter if you're assigning count to something, you're printing count, and you are interested of the value of count. Now we print the total because total, we define total outside, right? Outside you define it because you keep adding to it. And after that you do total in here, right? This is printing total, and total divided by 10, 12 divided by 10, 0.0 is going to give you, because this is float, or compiler is going to treat it as a double, floating point number, double. This is going to do total divided by 10.0. That gives you the average in decimal points. Now, if you want to use count, you can do count. But wait a second, is that going to be considering? So I'm going just to add whatever 12 10 times, because and here is 14 5 and another 14. Okay, now this is going to say 124 and 11. So what is the count value? What is the count value? Count value is 11, right? 11. So that should be count minus 1. But as you can see from the output in here, that, not this one. That was the old output. Now, this, if you tried this, I'm going to add. Now, this always gives you 7 or something like that, but this should be wrong, right? So first, count. What is the value of count? Count is being executed 10 times, so it's going to be adding numbers 10 times, so this is 11. But then integer divided by integer, right? Integer divided by integer. Let me just make sure that count is actually 10. So what I would do is see out count. I just want to see count because I don't want to assume it's 10 and it's not. So let me just do 1, whatever that is. Yes. And it says count is 11. So assuming count is 11, that was the right assumption because of my understanding of this code. And now count minus 1 gives you 10, which is okay. This is what we want. But that gives you integer, as you can see, int total. And this is going to give you int number, right? So you have to convert one of them to, or convert the value of one of them to double. If you're dealing with variables, not numbers, because we cannot do .0, remember from lecture 2? So what we do is static cast, and you're saying I want to convert that to float or double, whatever your preference is, and you have that in parentheses, right? So convert this value to float value and divide it by count minus 1. So if I try this, this should give me a floating point average. So 12, 13, 14, whatever that is, just numbers. As you can see, now I got those fractions, right? This is what I want you to see in practice. So once you're done, make sure that this is working and comment that because you want to get ready for the next thing or next exercise. Okay, so let's talk more about Boolean expressions. So you know that C++ contains the data type named bool, and bool has two possible values, true and false. You cannot have more than true or false. Now, you either have Boolean expression evaluated to true or to false, right? So what if you have your Boolean expression value, whether it's true or false, and you want to save it? I mean, you want to store it. You want to store it in a variable. That variable must be of type bool. Now, some of the Boolean operators would be called the logical operators. Those are not the greater than or equal or something like that. No. Now we are talking about the and operator, or operator, and the not. Now, in C++, we use the and, the ampersand in here twice, the pipe twice, or the bar twice, and one of the exclamation mark to represent not. Now, why twice in here? Now, you can use this once. It's going to give you the same exact result. But for efficiency purposes, we use the two pipes and the two ampersands. I'm going to explain to you what each of them mean, the and, the or, and the not. And I'm going to explain to you why do we prefer using the double, not the one, and so on. So we have something called truth tables. This is how we explain what this means, and so on. So truth table lists all the combinations of operand values and the result of the operation of each combination. What does that mean? It means that if I have Boolean expression, now whether this is a Boolean expression or Boolean variable, Boolean expression or Boolean variable, this is going to be combined with another Boolean expression or Boolean variable using the and or the or the only using those two. Now, or one of these two, like one pipe and this is not one pipe. This is one pipe, and this is or using one of the ampersands. Now, so we said all these things. What does this mean? What does this mean? It means that the and truth table would be the following. If I have a variable p, and this variable is storing false, or a Boolean expression, I'm going to call the value result of this Boolean expression P and Q. If I have P and Q, P and Q is checking whether both are true. You need both expressions to be true to get the final true. Otherwise, if any of them is false, then the combination using the and gives you false. What do I mean by that? I mean, if you have Boolean expression and another Boolean expression, and you want to say that I need both Boolean expression to evaluate to true to give you something. Some of the most famous examples I'm going to give you for the and for the or. For the and, you're great. You're great. I would say that if you get any number between 80 and 89, inclusive, like including the 80, including the 89, I would give you a B. Now, you would say, okay, how do I check those? I would say if your score is greater than or equal 80, the equal is the inclusive part, right? So score is greater than or equal 80, and score is less than or equal 89, you get a B. If any of them is false, you don't get a B. For example, let's say your score is 75. Is your score less than greater than or equal 80? No, false. Now check this one. Is your score less than or equal 89? Yes, it is less than or equal 89. So that is true. So false and true, false and true. That gives you false. So I do not give you a B. Remember, false means skip this line, skip the true block. right? So I skip that. I don't give you a B. Now, you may ask, okay, wait a second. I found this to be false, and I know, I need those two to evaluate to true to get a B. So it should be once I find the first false to skip. I don't have to even check those. Here's where this two ampersands come in play. If you use this 1 ampersand, then this has to check every one. Even if this one is false, it's going to check every one, then says, okay, false and true gives you false. But using those two, let me just get rid of these scrambles in here. So if I check this one and this one evaluates to false, if I see that I have and, then I say, okay, I have a false, I do not continue. But if I change this one with and I have a false, I would say, okay, I have to check this one, then find this true, then say true and false is false. So I skip. Again, if I have this and I have false first, then I say, okay, false and anything else, I definitely would get a false, overall false, final false, right? So I would skip. This is how it's being done. Same thing with the OR. With the OR, you need at least one true to get a true. Or in other way, you need all of the Boolean expressions to be false to get a false. So, for example, I have if age greater than or equal 5 or the weight is greater than or equal 50, I say the child needs or can use a booster seat. Now, if any of them were true, right? So, if the age is greater than 50 and I find this true, why should I bother checking this one? I don't need to, right? Even if this is false, I don't need to check. This is where this comes into place. But if I have just one pipe, one bar, then even if I find this true, I say, okay, I'm obligated to check this one. Even if I find it false, then I say true or false. Oh, this is true. See? This is why I said those two pipes or two ORs used for efficiency. And you're going to see that in the next few slides explaining those more thoroughly. Now, the not, it's just if you have false, you negate it. You negate that. Negate. Or we sometimes call it inverse it. Inverse whatever you have. False, true, true, false. That's it. It's like I want to gather some data. I see need data equal true. Once I'm done with gathering data, I gather enough data, I make this false. And then what I check is just the Boolean flag. And this is what we call usually in programming flag. Any variable of type Boolean, usually it's called a flag. Boolean is usually called a flag. So here is some logical expressions. I want you to think of the answer. So the first one, assuming that t variable include true, false, if include the false, or stores the false. So t and f, remember, you need all of them to be true if you're using and to get to the final true. So that should be false. Not if, that makes it true. True or true, that gives you true, right? Because if I said you have to choose between true and true, you have only two choices and both are true, so you choose true. For this one, you always start from the deepest parentheses, so those are the deepest, right? So not if, that gives you true. True and true, that gives you true. Not true, that gives you false. So we have false, true, false. Okay, what I was talking about having not the two or having the two, this is called the short evaluation circuit. And this is going to be in your test, by the way. There is a question in your test about the short evaluation circuit. Short evaluation circuit means that a Boolean expression is going to quit, is going to give you a final answer, to give you answer to the evaluation as soon as it makes an accurate decision. For example, like what? If this evaluates to false, in and with two ands, so the short circuit evaluation, if you use two ands or two ors. So if this evaluates to false, false and anything is false, right? So the need to check this one only if this is true. The need to check this one only if this is true. The need to check this one if this is false. If this is true, you don't need to check this one, right? Because you can make an accurate decision. True or anything is true. False and anything is false. So here is something, and you need to make sure you understand how to use it. You don't need, want to be falling in the bad usage of it. So while a less than 10, while a less than b, or plus count less than 100. So in your mind, when this count, the CNT is going to be incremented, only if A is greater than or equal B. Remember that if this evaluates true, then this is not needed to be counted, right? This is a bad usage of it. Let's take a look at a good usage of using the short circuit evaluation. A short circuit evaluation, you would say, only if I can read something from the user, only if I read something from the user, I would increment the count, right? So I would say if I can read something from the user, you would use the CN to take an input. If the user give you an input, not a corrupted input, then you increment the count. That means that I read something valid, right? I read something valid. Here's not good usage of the and. If I have this in here, okay, I increment first, then I check the count. No, wait a second. What if this is corrupted? If this is corrupted, it shouldn't be counted in the first place, right? So this is good, this is bad usage of the short circuit evaluation. Okay, so with the type conversion, as I said before, we have a strong intimate relationship between the character and int, right? As well, we have a strong relationship between the Boolean and the integer. Why? Because if you have true, Boolean true, this is going to be stored as 1 in the memory. If you have Boolean false, it's going to be stored in as a 0. And if you have a non-zero, it's going to be treated as if it's true. And if you have a 0, it's going to be treated as false. And we have seen this in this lecture, in this video, right? So you have to understand and memorize this because this is so critical to your understanding of C++. So we have something called normal statements. Normal statements is a statement that is not Boolean expressions, right? But they can be used as a Boolean expression. They can be used as a Boolean expression. Like what? If your Boolean expression going to be a normal statement, it's going to be dependent on a variable, right? On a variable or a value that does not include any Boolean operators or any logical operators like greater than or equal and all these things, right? So none of the logical operators or none of the overall Boolean operators. So this is going to be valid actually. And the loop is going to be finished when I is 0, right? When I is 0. So this is going to be saying 11, right? Evaluate 11. And 11 is non-zero, so this is true, right? Then it's going to do minus minus, but to be printed in here. So this is printing what? Printing 10, right? This is 10 printed. Then go back to check. While 10 is non-zero, so it's true. And print the I minus minus, which means 9. And keep doing that until you print the 0, right? Until you print the 0. So that is going to be printing all these up to the 0, printing the 0, even printing the 0, because 1 minus minus is going to print the 0. When you check the 1, you do after that a minus minus decrementation, and you print the decremented value, you print the 0, and you go back to check the 0. 0 means false, stop. 0 means false, then stop. So we can end the loop based on an input from the user, right? We can end the loop from the using the input from the user. So here it is. Once the user input is less than 0, I am going to say the user input in this condition makes this Boolean expression false. So for example, let me just explain this. I'm going to ask the user for input. Then, if the user input is greater than or equal 0, I'm going to do whatever I'm doing calculations in here and take another input to be checked. Take another input to be checked. If the user input is greater than 0 or equal 0, then keep doing that. Otherwise, you're going to skip the block. So if the user input, let's say the user input was negative 37. Then you take this from here, right? Go back to check. Once you go back to check, is the user input greater than or equal 0? No. Then false. Then skip that. Skip the whole block in here. Okay, so your class exercise right now is to ask the user for 10 positive integers, or if they want to quit early, they can enter a negative number. It's going to be something similar to this, right? Something similar to this slide. So you do it. Ask the user to enter 10 positive numbers. So they can choose to go up to the 10 numbers, or they can quit early after entering few numbers by entering this one. Entering a negative number. It doesn't have to be negative 34 like my example. It could be negative 7, negative whatever negative number is. And what I want you to do is not to count this in the total. Do not count it. So if I enter 23, 56, 4, 15, 37, and this is my this is 37. So this is my 6th number. So I'm going to count this, plus this, plus this, plus this only, and report the total and the average. And the average of this one is going to equal the total divided by the 5 numbers, not including the 6th. This is what you should do. Now you can do that in many ways. So pause the video right now, work on this, and when you work on this, you make sure you comment the last part, start working in here, then go back to the video and see the result. Pause the video and start working on it. Okay, assuming you came back to see the answer to this exercise, here is a solution. Here is a solution. And I say a solution. Now, you can do that in many ways, depending on how you think. And I always include a solution, not the solution, because this leaves a room for you to come up with a more efficient solution than mine, than this one, right? So here is the solution. I have int count equals 0 and a user input equal 1. Double total equals 0. I ask you for 10 positive integers or a negative to stop. While the user input is greater than 0, remember that I started with the user input greater than 0, right? So if that is going to be tested for the first one, that is going to be true. True, and the count is less than 10. Yes, it's less than 10 in here. So this is also true. True and true gives you true. So go inside. Ask for the first number. Now, the first number is going to be count plus 1, right? Count plus 1. Because you start with a 0. So take the user input, check the user input. If it's greater than 0, greater than or equal 0, add it to the total. Only if it's a positive number or a 0, you add it to the total, right? And only if you increment the count. Otherwise, no, you don't increment the count because you want the count in here to divide by, right? So total divided by count. Now, instead of me having those two variables, total and count, as integers, I had double to be total. I kept adding total, then double divided by integer gives you a double. So I don't have to do any conversion of any of those two variables because one of them is already a double, right? This is the solution to that exercise. Now, let's talk about random numbers. We're almost done. Random numbers are useful because generating random numbers is always useful in programs. Like in a game, any player does not want to have the same behavior of a game each and every time because for the first time I would enjoy it. The second time, I would say I would and still enjoy it, but then I memorized everything, so there is no challenge to me, right? This is without random numbers. With random numbers, you can have random actions. For example, if a player is walking, and the first time you have the plant, in here. Here is a plant with all these things. Now, this is a plant randomly placed in here, right? Randomly placed in here. So if the user is driving a car, he or she is going to have an accident when they come in here. The next time, they won't see a plant in here. It's not going to be in here, right? They walk and they randomly, when they get in here, it's starting to rain. And this plant is going to be in here. Right? So they don't memorize where they are going to have a car crash or when it's going to rain or these things in a game. So in a game, it's very useful. Also, in a simulation. Now, in a simulation in a complex system, like car crash simulation in a highway system, or likelihood of genes and cell mutations, or the weather simulations, randomly putting different values to different chemicals that would cause the rain to happen or not, and what the possibility of that based on the readings of these chemicals and all these things. So, for example, sometimes if you have a game and you want to generate a random, because if you throw a die, right, or two dice, if it's six-sided die, then you don't know what the outcome would be, right? It doesn't make sense in a game to always say, okay, the first die is giving you 2 and this one is giving you 5. Doesn't make any sense. Every time I roll the 2 dice, I should get a random number in the range 1 to 6, right? Or if you are throwing a fair coin heads 1, tails 2, the percentage of you getting heads is 50%, and you get the same percentage of tails. So you have to be able to do that in programming, because we need, as I said, random numbers for many of the systems, whether it's a game or a simulation or any other system that you're working on. So you can write an algorithm for generating what looks like a random number. Now, because it's an algorithm, we control the output and the input. And if we are controlling the input, we can control the output, right? Because pretty much algorithm is going to follow some formulas to produce the number, like f of x equal 2x plus 3. If I say x equal 2, you would know that 2 times 2 gives you 4 plus 3 gives you 7. If I say x equal 3, then you would say 6 plus 3, that gives you 9. And so on, right? So if I control the input, I control the output. So pretty much it's a pseudo-random number. It's not an actually random number, right? So how we do it in programming in C++ is we use the rand function. The rand function, it's from the cstdlib. So if you're going to use rand function, you have to include the cstdlib. So this returns a random unsigned int. The unsigned int is going to be the 64-bit int. In the modern compilers, or unsigned int in the range of 0 to the rand max. Rand max is 32,000 in the old compilers. So if you're going to write this program, what is this program's output? So we're including this library because of the rand, and we're including this iostream because we're going to use cout, right? So int I equals 0, while I less than or equal 5, cout random number, print a random number. Now a random number, right? A random number. So add increment I, so we do 5 rounds, 5 iterations. Right? 5 iterations. So what do you think the output would be? 5 random numbers. We don't know these 5 random numbers. But the thing is, since it's a pseudo-random number, and whenever you are going to start, the program is going to use the same default input. So since you're using the same exact default input, so the first sequence is going, I mean the 5 numbers when you run the program the first time, the 5 random numbers when you run your program the second time, with the 5 random numbers when you do it the third time, the fourth time, the millionth time, those are going to be exactly the same. Exactly the same, right? Because they're using the same exact default input. So how can we make it different. So every time I run my program, I want different output. Is by setting the seed, the input yourself. Now the input takes unsigned int, and to set the seed you use strand. So now I use strand, my input, instead of using the default input of set by the C++ creators. We have our input. Now this is going to give the seed to the algorithm as the starting number. Now otherwise it's going to use the default, which is the 0. Now every time you call rand, it's going to use this default random number as the first round's input. The second round's input depending on the first input. So if I do this right now, and remember that you always have strand, give it a seed once. Do not include this, because otherwise you're going to, if you put this strand seed in the while loop, you're going to set the seed every time, every iteration, which pretty much give you the same exact random number, right? The same exact random number. So if I'm doing this, I put the seed outside and I take the seed from the user. So I am doing this. I'm going to try this in front of you. So let me just take it to this slide. Where is that slide? That slide is in here, right? Yeah, this is the slide. Let me just take the contents and put them in the IDE. I put them in the IDE. Now, let me just show you something. We said we take the input from the user. Let's pretend this is the sequence. This is the sequence that is generated for the events of my game. So if the user said 4, then those are the events of my game. Those are the inputs for every event in my game. And remember those things, right? I'm going to stop that and run it. Now, this will be still here, right? Let me just show you something. My input was 4. If I'm a player and I want to cheat myself, like I'm going to use the same input, look, the same exact output. So what if I don't want the user to say what is the input? And actually, if I tried something else, like 5, those are going to be different output. Totally different outputs. Like this one is 54 and so on, right? Those are different outputs. Now, what if I don't want the user to define or to say what my events should look like in my game? I would get a unique value each time. The way I would do it is, what is the thing that is changing all the time? That gives you exactly a unique value each time. Okay, I may plead the words, right? Because the answer is time. I said, what gives you a unique value each time? And the answer was in my question, time. Because the time now is not the time 1 second ago, right? So how do I get the time? So whenever I run my program, it's going to be run in different times. Because if I run it right now, it's going to be run differently in next time, right? I get the time using the time function from CS library. Using the time function from CS library. And I make this time as my seed. Remember this seed? Instead of using this, I use this seed as my time. Right? So, here it is. Let me just show you something. Let me just take this thing, depending on the time. Now, you can ask me, okay, you use the random number, you use the seed in here without including stdlib, right? You're right, I didn't include cstdlib because in 2019, in Visual Studio 2019, the compiler is going to include the standard libraries when needed on its own. Certain standard libraries, like this one is a standard library. But if I removed it, right, the compiler is going to complain that it does not recognize the cout. So certain libraries. So I'm going to do this. I'm going to do this. Now, as you can see, because I said certain libraries or some libraries, it does not do that for you all the time. It's like just the famous library. And since this is not a famous library, it's not going to include it. So include C time. Now you can actually use time.h. But some libraries, some compilers, especially the very modern ones, they don't get to recognize time.h. So C time. Actually, time is a library from C. Any library that starts with C is a library from the old C. So now this is going to be recognized. Okay, that's good. Now, what do you think the sequence output would be? Is it going to be the same whenever I run my program? So let's run it for the first time. I would get 5 random numbers, right? Those are my 5 random numbers. Let me just stop this and I keep this one and run it for the second time. I would get 15,164, 15,138. So it's different. Let me just stop that and run this the third time. 15. So every time I run this, 15,206, 15,164. Now what you may ask, why 15? Why they are so close? They're so close because the time where I ran these 3 is close. So that was like 138, 164, 206. Now we spend some time explaining this, right? So is it going to be 15,206? Let me see. 15,334. As you can see, when we have time gaps, and running those, the time gap is bigger, right? 164 to 206 and 206 to 334. And if I come back in a few minutes and run this, it's going to give me something bigger than 15,138. Probably. Okay, now the sequence is different because it depends on the time, and the time is definitely always changing. So one exercise is verify the rand function. So create 4,000 random numbers between 1 and 4. You need 4 variables, right? 1s, 2s, 3s, and 4s. And if the random number generated in is 1, you're going to generate 4 random numbers. Now, the 4 random numbers could be either 1, 2, 3, or 4. So if it's 1, increment the variable 1s. And if it's 2, increment the variable 2s, and so on. Okay? Now you should get something like for each variable it should be happening at least like once, right? I would say at least once, or maybe zero. But the thing we get, because we would get random numbers in 1 to 4, we would expect to get the count of each random numbers happening in around the 1,000. So for practice, use while loop and if statement, and it should be different each time you do your input, right? Because it doesn't make sense that if two ran the first, could be happening, but it's going to be very, very, very rare. Why? Because you should be running your program twice in different times. If you and your friend ran your programs in exactly the same time, then you should get the same input, right? But this is so rare. You may have different milliseconds between your run and your friend's run. So pause the video right now. I'm going to show you the answer after you come back. So pause the video, work on this exercise, and come back to see the answer. Okay. As a hint, if you find this very hard, if you want to generate a number in a specific range, use these concepts. Now, these concepts actually using the modulus. Any random number modulus n, it's going to give you a number from 0 to n minus 1. And we had this rule in lecture 2, right? If I want to generate a random number from, for example, starting with 1, I would get this 1 plus 1, right? This is going to give you 1 to n. So if I want 0 to 99, I would say any random number mod 100. It's going to generate to me 0 to 99. 1 to 100, 0 to 99 plus 1, which gives you plus 1. 0 plus 1, here is the 1. 99 plus 1, here is the 100. Right? This thing plus 1. If you want something in a specific range, you do it this way. The gap in the range, like 2014 minus 1985, this is 30, right? This is 30. Range plus range mod 30. This is going to give you 0 to 98 plus the first number of the range that gives you 100. Let me just take this up there. So 0 to 98 and 29. This gives you after doing 1985, this gives you plus 1985. This is 9. This gives you 1985 to 2014. Right? This is give you 2014. So the possible output should be something similar to this. You won't get exactly what I get, because you're going to be having that in different times, right? And you're going to use seed depending on the time, right? Depending on the time. So you get something different, but you should get something close to 1,000 in each time. And here is the code. Here is the code that does that. So if I'm going to take this code, go there, take this code, and this is actually written in C in Visual Studio 2017. So if you're using 2019, do not include this. Do not include this. If you're using 2019, right? 2019, do not include the first one. I showed you that in lecture 1. So let me just take this one. I think this one, So this one is a photo. I'm not going to do this one. So if you're doing this one, make sure you understand the answer. Now I'm going to explain the answer to you in here, in this slide. Oh, wait a second. This slide. So what I've done is that I have 4 variables, as I said, for storing the number of 1 generated, 2 generated, 3 generated, 4 generated. And I needed the counter, I, and I needed temp, to check the number generated, So I need I to be less than or equal 4,000 if I'm starting from 1, or 0 if I'm starting from 0, then less than 4,000 to give you exactly 4,000 numbers generated. Temp, I'm going to say temp equal rand mod 4 plus 1. This is going to generate rand mod 4 gives you 0, 2, 3 plus 1 gives you 1, 2, 4. And this is the range we want. But remember that I asked you to make that dependent on the time. Dependent on the time, then you're doing this. srand static cast unsigned int times 0. Times 0 is going to give you something of type time. Convert that to unsigned int, because remember that srand takes unsigned int. Convert that to unsigned int, and this is going to give you a different start every time you run your code, different starting value. So you did that, and if you did that, and remember, do not have this in your while loop. Outside the while loop, you do it only at the top of your main in here. So you generated this, now you check the number. If the number is 1, increment the 1s. If the number is 2, increment the 2s. 3, increment 3s. 4, increment the 4s. Now you don't need actually if equal 4, because we know it's going to be 1, 2, 3, or 4. So if it's not 1, 2, 3, then definitely it's 4. So you can do just else. Then do not forget to increment the I, because you just need 4,000 numbers to be generated, 4,000 rounds, right? So that was lecture 3. Now at the end of this video, when you are done with all your codes, as I said, right click, open containing folder. That takes you to this folder, and go to submit this to this assignment as I showed you in the middle of the video. Now I can say to you, have a good day, and see you in the next video.